All right, welcome everybody out. Hope everybody is staying safe and healthy. This week we are going to talk about the Koala library, which is a library for using Excel spreadsheets to do work. Um, this has always been kind of a sticky wicket, integrating Excel into Python. So the libraries generally come in two categories. Um, for working with Excel and Python. Well, actually three. So um, I believe through the PyWin32 library, you can actually use a Windows interface to Excel to manipulate your spreadsheets. Um, but then if you want something that's cross-platform and doesn't actually require any sort of Microsoft software to deal with your Excel spreadsheet, then you are limited to one of two things. There is software there are libraries designed to open up the spreadsheet, make modifications, and save it back. I think it's OpenPyXL is probably the gold standard example of that right now. But one of the things that OpenPyXL does not do is it does not allow you to plug values into formulas and get the results back. All you can do with OpenPy Excel is get what the formula is. So you can read out the actual formula, you can't evaluate it. And so that's where libraries like Koala come in. Koala, you can load a spreadsheet, you can modify values in the cells. You cannot write it back out except in a special format for speeding up the loading of the spreadsheet later. So you can't load it back out, and but you can plug values in and get the evaluated results. Now there are some limitations on that, and there is actually two libraries that can do this. One is Koala, the other one is called PyCell. Now I've tried both, and PyCell has some quirks in it. I've done some reading on it, and apparently they are targeted at different audiences. Like PyCell is for, it's like one of the two is for aerospace, and the other one is for something else, things that are commonly done in Excel. And they are both written by companies to specifically to support their needs. And so neither PyCell or Koala are complete solutions. And that's important to keep in mind because I'm going to talk about some of the limitations that I've run into in Koala as far as unsupported functions, what can possibly be done to work, and what you can do to work around those limitations. But for our purposes, in at least where I work, we are using it to take a model that we was originally written it was created in Excel. We translated it into Python imperfectly, it turns out, but close enough for our purpose. I mean, it was close enough. But now we want to be able to update that model more frequently, and so I began doing research on ways that we could load this spreadsheet into Python and to uh, have it use the spreadsheet to do the math for us. And so I found the best example, the one that works for all of our code, or all of the functionality of the spreadsheet that we developed, was Koala. Now there were two things. There were two shortcomings of Koala that we did have to work around, but it turns out to be relatively simple. The other limitation of Koala is that, at least in its core repository, the stable version relies on, or the version that's available to the public relies on much older versions of several libraries, and in some cases that conflicted with the libraries that we used. Also, and a lot of this was revolved around the fact that the core release of Koala still supports Python 2, but the current version of some of the libraries that it uses are Python 3 only. So you'll notice that I haven't given you a link to their repository yet. That's because I'm not going to give you a link to their repository. I'm going to give you a link to my repository. So in the chat, I'm going to post a link to my repository, and this version, in my fork, I have gone through the effort of updating Koala to Python 3. So this is stripping out all the Python 2 support. Everything that's ambiguous about the code is all gone. Anything that was all the hangers on for Python 2 support are all gone, and all of the libraries have been pushed forward to their most current versions. I've gone through and ran all of their tests, and at least the ones that are not skipped, they all work. So you can find that here. I am not going to put this on Pippy because I've already put in a pull request. They have not, it's been outstanding for a few weeks now. I might prod them about it. But Koala is also not a very fast moving library, so I'm not sure how much time they're dedicated to working on it, or how important it is to update them to the latest and greatest. There are a few tickets in the original repository that are issues that are caused by the fact that Koala is basically still backwards compatible with Python 2 and it's using older libraries. And so people who need to use newer versions of those libraries are kind of stuck. And so they have to go in and modify the Koala source code themselves, or they have to wait until it gets fixed. So my version of this code, it's all fixed. It's all fixed. We are going to be using it in production shortly. I am not going to support, like I said, I'm not going to support it in the long term. I just want to get this stuff merged back into the original version of Koala so that people can just move on with their lives. Also, I have a branch called New Features, which we are not going to use or discuss. It has a couple of features that I would, I've added a few new features and fixed some deprecation warnings in the master branch, but I haven't documented the new features anywhere, and they are just for my use internally. They'll be useful generally. They're features that would be useful generally, but I haven't taken the time to document them yet, so we're just not going to worry about them. And it's, like I say, it's specific to our needs, and eventually I'll put in a pull request, but not until my main pull request goes in, then I'll put in the new features pull request. And like I say, I haven't documented it yet, so it's not, the new features are not ready to be pulled in either case. Okay, so then the question is like, well, if this is not on Pippy, how do you install it? So as you can see here, I've already got my virtual environment activated. If I list out the libraries, you'll notice that I do not have Koala installed. So pip can do something fun where you can do, and I'm almost certainly going to get this wrong, but you can put a dependence on a Python library in your setup.py file or your requirements file, or you can do it manually with pip. I'm not going to go over how all of the different ways to do it. You can Google it, and there are plenty of examples on Stack Overflow. But I believe if we just do pip install, and I think we can just do this. Okay, error cannot unpack. Okay, so what we need to do is we need to give it a tar file. So I believe the way we do that is, oh gosh, it's going to be the download. It's going to be the download link. Actually, it's going to be the download tarball. And so if we go, nope. Because if you can point pip at the tarball that has the setup.py in it, and it will download it and get it. And I always forget how what the link is. So I'm going to stop sharing so I can look at something that's internal, because I do this, like I say, I do this on my own project stuff. And I just don't want to accidentally share something that I'm not supposed to. So setup.py. Let's see. Zip files. Okay. All right. There it is. So I believe we can just do this. And let's turn our sharing back on. to share. All right. So we can do pip install, and this is actually linked to a tarball, but we want, so we can install the new features branch or we can install master. So if we do that, yes, it worked. Okay. Okay. And this will also go ahead and install all of the requirements. So let's see. I'm not sure what etXML file is, but it does actually install OpenPyXML, which is kind of amusing because Koala doesn't support writing out files, but you can use the OpenPyXL to do it. It also requires, in fact, we can look at setup.py here real quick. So the requirements, at least in my version, it requires network X, it requires PyOpenXL, NumPy. It does require Python, although I'm not sure why. LXML for actually parsing the XMLS file. So for if you're not aware, an XMLS file is actually a bunch of XML files in all zipped up together. That's really all it is. So if you want to look at the innards of a modern Excel file, you just literally rename it to a zip file, unzip it, and you can explore all of the XML files. 6 actually shouldn't be required anymore because I think I ripped out all of this. Is actually an error because 6 is no longer a requirement. I went through and ripped it out. Let's see. It requires SciPy. In fact, let's see. Backports. That actually does not look current. Hold on one moment. Go to new features because all of my fixes should be in the core. Yeah. Okay. So that's a problem. I'm going to need to go in and address that. There's a NumPy function that is no longer built into NumPy. It moved into a separate package that Koala relies on to do some of its calculations. Oh, and 6 is gone. That's weird. Okay, so you know what we're going to do is we're going to change this to, I think I can just paste this in again. So I guess we are going to use the new features branch. Yeah. Successfully collected packages, successfully installed NumPy Financial. Let's see. Oh, it did not install the new version of Koala because of the, let's see, collecting decorators. Okay, so it looks like it actually, let's see, pip. So pip will say, oh, you've already got Koala installed. I didn't bother to install it again. Okay, so we're going to do pip uninstall koala2. Let's see, yes. And then we'll do that. Okay. So let's see. Using cached. Okay, so that actually should be current. Okay. I didn't actually see it reinstall koala2 when we updated that. This is actually the big problem with this is the problem you can run into trying to install from GitHub. So yeah, okay. So looks like I need to address a few tweaks in my setup.py file. So maybe I will just merge all my new features branch into my pull request branch, and they'll just get the new features with the pull request, and that'll be that. So, okay. All right. So most of this is actually documented um, on the home page. But first thing we're going to do is we need to make a spreadsheet that we can use to evaluate this. So I have one sheet called sheet 1, and we are going to put some values in here. And 1, 2, 3, 4, 5. And over here we will do and some, and let's go like that. Okay. All right, so that gives us a total of 15. So this is the really simple example in our spreadsheet. So what we are going to do is we're going to load the spreadsheet in, and we are going to tell it to evaluate this this cell. So the way we do that, and I'm just going to follow along in our just going to follow along in the documentation. So we're going to go from koala import, actually, let's see, koala dot spreadsheet import spreadsheet sheet. Okay. And then we are going to create a spreadsheet object. Now we're just going to get this out of the current directory. So we're going to go, oh, helps if I learned how to spell import. There we go. Spreadsheet, and then we specify example dot xmls. Okay. Now I have a sinking suspicion that I've gotten my import incorrect. So let's go ahead and try and run this and see what happens. Okay. Import spreadsheet module, no module named koala spreadsheet. Okay. So I think what we actually do is from koala import spreadsheet. And then if we go ahead and spreadsheet.py, yeah, okay. Unresolved reference spreadsheet. What? Liar. We're going to save that. Go ahead and run it again. Spreadsheet. Did I spell that right? There we go. Ha! Okay. Okay, no such file or directory, example XMLS. So let's see, we've got save. Did I put example XL? Oh, ha! XLSX. Okay. Typos and other silliness aside. All right, we've loaded our spreadsheet. Okay, so now let's get back to how we actually read this. So we're not going to serialize our graph. We are more concerned about graph evaluation. So I'm going to keep pulling the spreadsheet back in to remind us of what things look like so that we can go forward. Now, when you want to evaluate any value in your spreadsheet, you use the cell evaluate. Now, one thing you'll notice here is that they always include the sheet name. That is because there is no concept of current sheet. It is, you always have to specify the sheet. Now, one of the things I added in new features was the ability to list off the sheets. So if you don't already know it in advance, you can get it. So there is, there is that, but there's no concept of this is the current sheet. So when you call any of these functions, it just says, oh, this is the current sheet. So we're just going to use that. Now, other libraries like PyCell and possibly OpenPyXL do have the concept of current sheet. Like you do all of this through a sheet interface. You do the same things versus a sheet interface. In Koala, everything is global. There's one interface, and so you have to be unambiguous. So let's go ahead and call cell evaluate equals cell evaluate and sheet, and we're going to call it on A1, A1, and then we'll just go ahead and print it out. Print, let's see, A1, and then B. All right. So that should give us the value of 15. Yep. Okay. So how does this all work? So when Koala is loading a spreadsheet in it, what it does is it takes all of the formulas and it transliterates them all into equivalent Python code. Now that code is buried in, it uses, I believe it uses NetworkX to handle references. And what it does is the Python code is basically a, hey, take the sum. In this case, the equivalent code is call our sum function on this range right here, and then there's a internal library function that says, okay, well, let's get cells B1 through B5 and return them as arguments to our sum function. And that's pretty much it. It's just going through, and it does it one time when the spreadsheet is loaded, and then from then on, it's executing all Python code. There's no reevaluation. Now, there are, so now let's do the other half of this equation. Let's modify the value. So we can call cell set value. And we're going to take, let's see, B, let's say, yeah, so let's take B5. And it's currently is 5. Let's go ahead and set it to 15, which will add 10 to our results. So we'll need to reevaluate the cell and print it out again. And it adapts accordingly. So this is all fine and great. So I mentioned some limitations before, and now is probably a good time to discuss those. So you'll notice that we have a range expressed here. So one of the problems we ran into is if you want to express a range that's on a different sheet, and or even if it's on the same sheet, what you can do is, and it's not required that you put it in quotes, but if your sheet name has spaces in it, you need to sheet 1 and then pound, and then exclamation point, and then the range. Okay, so this, you'll notice they removed the quotes for me automatically. So let's see. Okay, so I saved that. So if we run it, we still get the same values. Okay, well, that's fine and good. Well, the other thing that you can do, so we've got this range, we can actually specify it like this, and you'll notice that the preview gets confused. So if I go ahead and accept this, we still get the right value back. However, you'll notice that the preview is like, well, you've got here and you've got here, but even though you're actually expressing a range, it's weird. And it's actually I think this is a bug in the Excel preview. But here's the real problem is when you run it, oh, it's still got the right answer. That's weird. Okay, so what I'm going to do is rename sheet space 1. All right, so now it's put the single quotes. This might actually be what's causing the problem. So, okay, so we still got this weird preview thing. We're going to save it, and we're going to run it again. Sheet 1 is not in. Oh, ha, ha, ha. Okay, so now I actually have to put a space in these. Let's see. All right. You'll notice that I got the exception cell sheet 1, B5 is not in cell map. So yeah, because I put a space in the sheet name, so now I have to fix it in my code. All right, now both of the values are wrong. And this actually narrows down what the actual bug is. So if your sheet name doesn't have spaces in it, it'll still work. But if it does have spaces in it and you have to put quotes around it, this is where Koala will fail to evaluate it properly. And the cause, and it's because I've put the sheet name in when I express the range, which is actually not necessary. This is equivalent. Now, if I change it to this, even though my sheet name has a space in it, it will get the right answer. So that's something that you have to watch out for. And one of the things that I did before I gave the all clear to use this library in production was I took sheets that already had input value. So our sheet is basically there are cells for inputs, and then you get results out of some output cells, which is the most simple and rational way to use this thing. Um, uh, I would look at a sheet that was already pre-populated, load it up in this library, and then just look at the outputs to see if they matched. And this was the thing. This was the problem that it took me a couple of days. Well, it was about a day of digging around in the library internals to figure out what was going on. And what I believe the actual problem is that it's a tokenizer bug. So when it tries to break up, when it tries to break up the range, if it's got a space and it's got quotes around the sheet name in the second half of the range, it gets confused. And you'll notice that it's evaluating this range instead of showing it up as a range. And the first time I ran it, it's only seeing the last cell in the range is what is happening. So that's just something to be aware of. The workaround is, of course, don't include the sheet name in the second half of the range. So then what's the other problem? Well, okay, so is you'll occasionally run into unsupported functions. So it is that there is quite a lot of functionality that is supported. It's actually quite good. Like the match and if functions are supported, so you can do logical branching in your Excel spreadsheet, and that at least the way that we've done it, it still works. We have our spreadsheet selects a series of values from a column based on a value that you give it. It says basically matches the name to all the columns are labeled with one of the rows is labels for the column, and it uses match to figure out which column to actually pull stuff from. That works as expected. Relative and absolute references work as expected. Named cells work as expected. That one's really important to us because we want to be able to name cells, or they're called named. Technically, they're called named ranges. Named ranges are completely supported and work as expected, which is great because we want to use those so that the person who's developing our spreadsheet can just name the cells for the inputs and for the outputs, and then we don't have to worry if he's moved them around. So that works as expected. Let's see. If works match works. If works exactly as would expect. We have conditional logic for whether or not to pull from one or two values based on the contents of another cell. That works as expected. So for us, at least, outside of the one unsupported function and the range issue, it's worked great. So the other thing that you need to so the function that we ran into that was not supported was actually convert. So let's see. Let's go B1 and then from unit. Let's say grams alert you've entered into. Yeah, geez. Okay. Let's go from grams to ounces. Will that work? Not available. Grams to pounds. I don't know. I never used this. Let's see. Pound. Okay. I don't know why this isn't working. So we're taking B1, converting it from grams to US pound. Okay, so one I know that works is meters squared to US acre. There we go. um, so if we run our code again, let's see, did I save? I did not save. Gotta save. If we run our code again, it works just fine. So, but I made the claim that convert wasn't supported. Well, if you never actually have to go through, if the cell you're evaluating never has to go through a cell that is using an unsupported function, it'll still just work. So you can use unsupported functions in the parts that you're not interested in interfacing with your code. But if we go here and we say, okay, cell evaluate A1, so let's do cell evaluate C1, which has our unsupported function in it. C1. And I don't think this thing is actually case sensitive, but I'm doing it just to be safe. So if we try and run that, then we should get a exception, problem evaluating name convert is not defined for sheet 1. So my understanding is that there is a relatively, they've got the framework set up to make it relatively easy to add new functions. And we were using convert in 2 places. And convert is actually a really easy function to replace. You just look up the conversion factor and you just do the math yourself. And so we just did that in 2 places and we're fine. But if we wanted to implement convert, there's actually a Python library called Pint, which is for unit conversion. And with the appropriate name mapping, you could probably get Pint to do the convert functionality correctly and completely, although it was like 2 days worth of work versus 2 minutes worth of work to fix it. So we went with the 2 minutes worth of work. Although convert is a very popular function, especially if you're you're converting from metric to imperial, which we do that quite a bit. What we do that somewhat here. So currently, convert is not supported. Although if I was going to add any functionality, it probably would be convert because I can see a lot of application for it. And there's, like I said, there's a clear path forward using the Pint library to implement it. Okay, so let's see if there's any other functionality we need to talk about. Oh, get over back here. Okay, so we can set the cell value. We can get the cell value. You can use named ranges. The only thing that I am not sure that you can do is add your own named ranges. So let's see. Yeah, because the cell, actually, you can create the cell objects yourself and add them into the spreadsheet object. And I think you can add there's a way to add the name ranges to that, but it's not documented. You have to dig through the source code to figure out how it's done. And I don't know how to do it off the top of my head. Okay, so the library, because the library is designed for high performance, you can also mark cells as volatile or non-volatile. And what that does is you can what am I trying to say? It allows you to tell the underlying engine that these values don't need to be recalculated. And so after creating the graph, you can use clean pointers to fix the values of pointers to their initial values, which reduces the graph size and decreases evaluation times. So if you've got um, if you've got um, if you're pulling out like 100,000 values um, out of your spreadsheet, and they all rely on a particular set of cells or one cell that whose values are never going to change, you can call clean pointers, which will fix everything to its initial value, and this will allow you to execute the spreadsheet a lot faster. We don't see the need to do it and it kind of runs counter to the way we currently use our spreadsheet. So I haven't actually messed around with it very much. But if you're trying to use a very large spreadsheet and get a lot of values out of it, then it's worth looking into that functionality. Um, let's see. You can also, oh, this is actually rather interesting. You can specify the outputs that you need. In this case, all cells not concerned in the calculation of the output cell will be discarded and your graph size will be reduced. So um, that is actually something I should look into for, he's actually got a typo in here. He's missing his quotes. So you can there are things that there are tools available to prune the graph. So if somebody's got like extra sheets that um, all the extra sheets that you have that might cause it to take longer. So there is an issue with load time. If you have a particularly large spreadsheet that has extra sheets that you don't need, it will attempt to load them and evaluate them, and that can be time consuming. So one of the new features that I added in was, so there was the ignore sheets option, which says you can list off sheets that you wanted to ignore. I added a sister option to that called include only, which will not load a sheet unless it is in that list. And because in our case, we know that there are 3 sheets that have everything that we care about. But it looks like I can take it a step further and regenerate the graph and then prune all the inputs that don't have anything to do with that graph, which will reduce the size of the model in memory. Although our spreadsheet's not huge, so I'm not terribly concerned about it. You can fix, so this is something that they are thinking about setting up so it'll happen automatically, but for right now you have to do it by hand. The thing that I mentioned before about cleaning pointers, um, you can actually essentially do the same thing to specific cells so that you can say, so the value is not reevaluated every time. Again, if you have like 10 or 100,000 cells that you need to evaluate and they all depend on 4 values that were difficult to compute in the first place, but their values are not going to change, you can fix their values to speed up the calculations of the other cells. By default, all cells which you use cell set value will be fixed. So that's, of course, makes sense. And you can free them. You can free them to allow them to be reevaluated by calling cell free. When you call free cell, it is automatically reevaluated. Okay, so we can also set formula. So formula, basically you name a cell and then you plug in a formula and it will add it to the graph. So the string argument you pass in needs to be in Excel form syntax. You leave out the equal sign, and it will just plug it in. Let's see. You can let's see, pointers to I'm not sure exactly what detect a live pointer is, so I'm not too worried about that. But because of how all this works, you can actually create a spreadsheet object from scratch. Now, of course, you can, like I said before, you can't save it out, but you can call cell add. Now, this is actually another quirk that I should mention here. So let's go ahead and take out this evaluation of C1 because it doesn't work. So let's do cell set value, and we'll set the value of B6. And we will and we'll set it to 15, and then we won't do anything else because I don't think we really need to do anything else to demonstrate this. So this is another quirk of the library that I'm not it's I think I have a workaround for it that I may add in, but there's an easy way to deal with it. So if we run this, we're going to get an error, and it says cell sheet 1 B6 is not in cell map. So that cell does not actually exist in our spreadsheet. So we have to call cell add instead. And then we set value equals to 15. Okay. Well, what if we do this and we change it to 16? Okay. So the first call will work. The second call will fail because of the inverse problem. You're trying to add a cell that already exists. Okay, so how do we deal with that? I mean, that's kind of obnoxious. So what we do is, if we are not sure, and this is even though a cell is referenced from a formula, it doesn't necessarily mean that it exists in the spreadsheet. Because if you looked at it in Excel, it would say, well, there's no value is available because some of your arguments are empty cells, and that means that the cell might not actually exist. And so in those cases, you can go if let's see. So let's specify our address here. ADDRESS. How do you spell address? That's how you spell it. That's how I'm spelling it. So we're going to reference that, and then we'll just get rid of this line here. So if address not in SP, so cell map, and address not in SP named ranges, then we call add. Otherwise, we call set value. And we can actually set this to value equals and address like that. And actually, if you want to clean this up a little bit, what you can do is you can change this to set value like that. And then regardless of whether or not address exists, it will do the right thing. It should be noted that cell set value uses positional arguments, but the positional argument is named value, so this will still work. And this one uses a keyword argument for value, and if you try and just use both positional arguments, it will fail because the second argument is not the value, it's something else. So then we can come in here, and this will just work like so. Graph construction updated 13 nodes, 13 edges. Okay, so there's actually a print statement in there somewhere that probably needs to be removed. I did notice that they don't use the logging module. They use they're just using print statements. So that might be another thing I do is go in and replace the setup logging and um, yeah, set up logging and then run and then set all that stuff to debug level so it'll just go away. um, so yeah, um, but yeah, graph construction updated. That's what happens when the cell is actually added. So yeah, that's all I've got. Are there any questions? Wow, that came out to almost exactly an hour. Perfect. Okay, if there are no questions, we'll call it a meeting. Thanks for coming, everybody.
Thank you.